Hi girls, today we're going to be starting Unit 4. Unit 4 has to do with descriptive statistics. Lesson 1 is working with a single measurement variable. So first we're going to talk about representing data sets. Now data sets can be represented graphically. And one of the ways we can represent it graphically is by using a number line. So we would draw a number line and then we would just place a dot each time we saw that number occur in our data. Another way that we can graphically describe or show our data is using a histogram. So a histogram, we also have our number line, but this time we have an x-axis and we have a y-axis. And our data is represented by rectangles that go above the number on the x-axis to a value for the y-axis. A couple of numbers that you've seen before are mean and median. I know that you've calculated those before. We call those measures of center, or sometimes they're called measures of central tendency. Is my pen working here? Measures of central tendency and variability. So the mean is the average, and we know how to take an average, and the median is the middle number. So when you place a data set from lowest to highest, the median is always the number in the middle. Quartile ranges, we're going to discuss that a little bit later, but you can always come back and reference these vocabulary words. So let's look at our very first example. And this example is in your workbook. And let me get the page number. So it's workbook pages 9, 10, and 11. So example 1 is on workbook page 9. So let's read the problem. A pharmacy records the number of customers each hour that the pharmacy is open. The staff is using the information to determine how many people need to be working at the pharmacy at each time of day. The number of customers is in the table below. Use the table to create a histogram to help the pharmacy staff understand how many customers are in the pharmacy at each time of day. So you'll notice along this side, we have our times by hour, and then on this side it lists the number of customers that are showing up. So the very first thing that we need to do is create our number line. So in this case, move this down a little bit, we look at the range of the data that we have, starting with (8 o'clock), and the time goes all the way up to 5 o'clock. So on our x-axis, we are writing the range, starting with 8 a.m., going all the way up to 6 p.m., and as you can see, each interval is 1 hour. 8, 9, 10, 11, 12, 1, 2, 3, 4, 5, 6. Next, we take that same data, I put the table here, and we decide how we're going to, with numbers we're going to put on our y-axis. And that has to do with the number of customers that we see in each of those hours. So our lowest number was 0 and our highest number was 23. So on our y-axis here, we're going to start with 0 and go all the way up to 24. And now we just draw the rectangular bars that match each time period. So from 8 to 9, there were 2 customers, so we draw a line up at 2 customers, color in the bar. There were no customers from 9 to 10. 10 to 11, we had 8 customers, so the bar goes up to 8. And each time you are creating the bar based on how many customers there were. And we're done. That's it for our histogram. We have graphically represented that problem. All right, let's take a look at example number 2. Anna and Ethan watch 30-minute shows during the month of June. They record the number of commercials that air during each show in the table below. Create a dot plot to display the number of commercials that aired during the 20 shows. All right, now what's important about a dot plot is that our numbers have to be listed from lowest to highest. And when we go and we look at our table, our numbers are not listed from lowest to highest. They're listed based on the television show. So we have to take that data set and we need to now write it from lowest to highest. So as I look here, I see the lowest number that I have is 12. So I'm going to rewrite over here 12. Next I see, I know there's a 13 here somewhere. There it is. 13. There's a 14. Another 14. 14. And I think that's it. I see 15. 15. 15. Notice how I'm crossing out the numbers so I don't repeat them. 15. I think that's it for 15. So I see it. 16. Scroll down a little bit. I think that's it for 16s. 17. 17. Just on my page. 17. 17. 17, that doesn't look like a very good 17 there. And, okay, so 1, 2, 3, 4, 5 17s. I have an 18, 18, 18, 18, and all that's left is the 19. All right, so when I look at, let me make this a little bit smaller. There we go. So when I look at my data, I have them going from lowest to highest. So when I write my number line, I know that I'm going to have to start with 12 and end with a number 19 or greater than 19. So I made my number line. I started at 12, my lowest number, and went to 20. And you'll notice each interval is going up by 2. Oh, no, I'm sorry, this is going up by 1. So 12, 13, 14, 15, 16, 17, 18, 19, 20. Next thing I do is I go back and I look at my data that I've placed in this order. Let's see if I can grab this data and transfer it. I think I got it. Copy. All right, there it is. So now I'm going to place a dot everywhere I see a data point. Let me do this in red. So I've got a dot at 12. I've got 1 at 13. I've got 1, 2, 3 at 14. 1, 2, 3. 1, 2, 3, 4 at 15. 1, 2, 3, 4. And notice how I'm trying to line them up horizontally as best I can so that these dots all line up. 16, I just have 1. 17, 1, 2, 3, 4, 5 17s. So 1, 2, 3, 4, 5. 18, 1, 2, 3, 4. Oops, I lost my 19 down there. 1, 2, 3, 4. And it looks like my 19 from the previous page didn't transfer. And so I have 1 dot at 19. And that's it. That's my dot plot. I have now represented my data graphically as a dot plot. So let's look and see how nice it looks when it's done professionally. So again, We've taken our word problem. We've been able to represent data in a table that is not always easy to interpret in table form, and it's easier for us to understand when we see it graphically. All right, let's look at our last example. Example 3 says, the website Rate My Phone conducts reviews of smartphones. One aspect of the phone that is tested is battery life. The minutes of battery life for the newest 25 phones is reported in the table below. Draw a box plot to represent the data. Now, this is something we didn't discuss before. It has to do with our quartiles. So let's look at our data first. You see the smartphones are listed from A to Y, and the battery life is listed next to it. So that means we have 25 pieces of data. They are not currently in numeric order from lowest to highest, so we need to write them that way. So this is going to take us a little while to do. So I'm going to move to the next page, which is smaller, and actually look at this and write them from lowest to highest. So when I did this, I know that I've got 250, 260, 280, 290, 300, 320, 330, 340, 350, 360, 370. All right, I'm going to start back up here. 380, 390, 430, 440, 470, 490, 510, 520, 530, another 530, 550, another 550, and then finally 730. Let's make sure I've got them all. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. I forgot one. Let's see what's missing. Oh, there's one. There's another 520 in here. Sorry about that. So that makes my 25. So now, a box plot, which we haven't talked about before. In the first step of finding a box plot, we need to find the median of our data. And we said earlier that the median is the middle number. And when I counted, I had 25 pieces of data. So that means I have a middle number. It's an odd number, so I'm going to have a number in the middle, and that's going to be, there'll be 12 on one side, 12 on the other for 24, so the middle number will be the 13th. So let's go through and count and find that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So our 13th number is 390, so our median is 390. I don't know why, but there it is. So 390 is our median. That's the first number that we need to find when we're going to make a box and whisker plot. All right. So in this case, again, I start with my number line. And when I looked at my data, my minimum value was 250. My maximum value was 730. So my number line is going to start at 250, and I've got it going up to 750. And if we notice, each one of these tick marks is going up by 50. So, I should say, we've numbered each going up by 50, but each line would be going up by 25. the next step in the process is to go back to our data, and we need to find what we call the first quartile. So let's go back to our data. Now, we found the median. Let me highlight this. We found our median by finding the middle data, the middle number of the entire data set. Median is the middle number of the entire data set. The next thing we're going to find is the middle number of the first half of the data set. Our median cuts our data in half. So now we're just going to look at the 12 items that come below it. So 12 is an even number, which means there is no middle number. There's going to be 6 on one side and 6 on the other. So let's figure out where that middle falls. 1, 2, 3, 4, 5, 6, 7. So our middle falls right here. Since there's no actual number there, in order to find this middle number, we have to find the average or the mean of these two numbers. So I've got 320. I don't know why that is happening. 320 plus 330, and then I'm going to divide by 2 to find the average. So that's going to give me 325. And we call this the first quartile. Okay, so a quartile represents a number, and it's the median of the first half of the data. The next number that we need to find is the median of the second half of the data. Here's our median again of the entire data set. I have 12 numbers below that. I need to find the median number of those 12. So that means I need to go to numbers 6 and 7 again and find what the middle number would be. So 1, 2, 3, 4, 5, 6, 7. Now 6 and 7 are both 520, so the middle number between 520 again would be 520. So in this case, 520 is what we call our third quartile. So now I have 3 very important numbers to help us with our box plot. We need to have our first quartile, oops, yikes, I lost my data here. Oh, there it is. Our first quartile, our median, and our third quartile. So these are the 3 important numbers that we need when we're making our box plot. So let's go through the steps of making that box plot. So the first thing that we do, again, we make our number line like we had before, our min and max. And then we draw a box beginning with the first quartile, 325, 325, we draw a line. Our box ends with our third quartile at 520. So we draw lines above the graph that will create a rectangle for us at our first quartile and our third quartile, and then we draw in the rest of that rectangle. So we put our line here first, we put our line here first, and then we complete it with our box. The next thing we do is we draw another vertical line at our median. So now I have 3 lines. Now it's not always going to split our rectangle in half. It's going to split it into 2 parts, but not necessarily 2 equal parts. Our next step is to take our minimum number, which in this case was 250, and our maximum number, which was 730, and we place dots, minimum and maximum. And the final step is to draw a line from the minimum dot to the rectangle, and then we go to the maximum dot and draw a line back to the rectangle. And this is what we call a box plot. Sometimes it's called a box and whisker plot because these are considered the whiskers. So this is a third way of representing our data. So when we come into class on Monday, we'll do some more example problems together, and we'll practice creating all three types of these graphs. Enjoy the rest of your weekend.